So folks, let's start with our basic programming in JavaScript. JavaScript is a very vast language, and to be very honest, not only JavaScript, but a lot of languages like C++, Java, JavaScript, Ruby, all of these languages are very vast. You cannot expect yourself to be a master in these languages in one day. Just think about it like English. You spent like what, 7, 8, or maybe 10 odd years in your school days to actually master English. And to be very frank, still we have a lot of things to learn in English, right? We also don't know everything in English, something that we spent what, like 10 odd years. Similarly, these programming languages also demand a lot of dedication, right? There are a lot of advanced corner concepts that are different in a lot of languages. But the best part about programming languages is for getting started with them. If you want to just getting, if you just want to get started with any programming language like C++, JavaScript, Java, anything. So for getting started, if you somehow understand one language, then for getting started on another language is going to be what, maximum 3 to 4 days task, because the concepts, the foundational concepts, right, that actually are taught in the start, or you have to understand in the start, are common in all of the languages. That is the best part, due to which we will be able to handle most of the things very easily, right? So my point being that if you are getting started with JavaScript, don't expect yourself to become a master in JavaScript in like one day or 1 week. Here we are going to first of all start with beginner JavaScript. Later, maybe in some other parts, we can even take advanced concepts of JavaScript. I'm teaching you JavaScript till an extent that we can at least get started with algorithmic problems, data structure problems, right? Puzzles and everything. So make sure that you keep your patience, right? You sit back tight, even if you already know some language, right? Because once we are done with the basic part and we do a bit of algorithmic stuff, the advanced part of JavaScript is going to be extremely interesting. So let's start. So now we are going to start with basics of JavaScript. Basics of JavaScript, right? Okay. Now JavaScript is technically a multi-paradigm programming language. In JavaScript, you can do functional programming also, procedural programming also, and now you can even do object-oriented programming also. I guess everybody basically knows that, and we are going to eventually talk about being multi-paradigm again when we'll come to the advanced stuff. But JavaScript is just like any other programming language. The basic foundational concepts are same. So let me take another example in front of you. So let's say, so I'm going to open a browser window in front of you. Okay. Now I believe everyone loves games, right? So I'm going to search for online tic-tac-toe. Okay. I'm going to search for some like online tic-tac-toe. Okay. So let's see. So this is the first website that I'm getting. Looks fine to me, right? There are a lot of ads although, but we can just close them up. Okay. Now on this website, you can see there is a bit of UI, right? There is player X, there is computer 0. So we will be playing with symbol X. Computer will be playing with symbol 0. If the match will be tie, we will get it here. So let's see. If let's say I put a X here, I click and I put a X here, then the computer puts a 0 here. Then let's say I put a X here, computer puts a 0 here, and I put a X here, and we win, right? And we win. And you can see, because we win one game, the counter is 1 here. The counter you can see is 1 here for player, that is us, and counter is 0 here for computer, that is the automated computer system. Now you might be thinking why I am telling you, right? You might be thinking why I am telling you. So see, if I click another anywhere on the screen, it starts another game. Let's try to win this game as well. Okay. So now You can see we won another game, and you can see now the counter is 2. Now the counter is 2. Okay, looks fine to me. If I refresh, if you are not able to see the counter, let me just zoom in a bit. So you can see the counter is now 2. If I refresh, you can see the moment I refresh, everything got refreshed, right? And the counter is 0 again, right? Let me zoom in a bit. And the counter is 0 again. You can see the counters are 0 again once I refreshed. So what is going on? What do I want to actually tell you guys? So let me tell you. So any piece of software that you are building needs to store some information, right? For example, the tic-tac-toe, that the game that we just saw, it has to also store kind of like some piece of information. That is, let's say, what is the score of the player, right? Or maybe in your tic-tac-toe grid, what positions computer has marked, what position I have marked, right? These things need to be stored somewhere, right? These things needs to be stored somewhere. If let's say I refresh the game, if I refresh the whole piece of software, let's say refreshing on a web app is equivalent to saying you just close the application and run it again. So everything is refreshed. All the storage spaces are reset. Now the player's count was again 0 and computer count was also again 0. You have to restart. My point being, in any piece of application that we are going to develop, we need some space, some area to store our data. Some area to store our data. Now, what actually happens is, whenever we run a software, let's say this is a piece of software, right? Some software, right? This software must have been written or coded in some programming language. So I'm going to say this is the code of some software. If I want to run the software, then what actually happens is we call this piece of code of the software as a program. This is a program that we are going to write. For example, let's say if I want to build my own tic-tac-toe, I have to write some JavaScript knowledge that we are going to eventually see when we are good with JavaScript. So we are going to write some piece of code, and once that is done correctly, we will be able to play tic-tac-toe on it. So the coding information that we are going to write in a file is going to be a program. What happens is, when you want to run this program, right, there are different ways to run it. Different languages are going to be run in different ways. When we are going to run it, this program, which we have stored in some file, right, this is going to be loaded inside our RAM. So let's say this is our RAM. What is RAM? RAM means random access memory. This is the primary storage area. Inside this RAM, let's say I have a 4 gigabyte RAM, for example. So what happens is, when you want to run this piece of software or run this program is loaded inside your RAM and it becomes a process, right? It becomes a process here. So you can say that program in a running state is called process. Simple terms, if I define process, in a running state is called process. So whenever we run this piece of software, it becomes a process. For example, let's say I open a Chrome browser or Mozilla browser, right? So somewhere in your computer system, you have downloaded the whole setup of Chrome, right? So all the piece of code of Chrome is there. When you double click on it and try to run it, then that program that is stored, which was not getting used until or unless you ask it to be executed, when you double click on it, that program is loaded in the RAM for execution. And when it is loaded in the RAM and the execution starts, it becomes a process. So a program in a running state is called a process. So if you want to see all the process in your computer system, if you're using Windows, you can open Task Manager. I am assuming that you might have been already well versed with Task Manager. So on Task Manager, you will see a lot of tasks, or you can see a lot of process, right? So for example, if you will double click on VLC Media Player, you will see a new process that will pop on the Task Manager, right? In Mac, you can even have System Monitor. I guess it is, 1 second. I forgot the name. Let me just quickly check. Just second, let me show you on Mac. Activity monitor, sorry, it's not system monitor, it is activity monitor. Right, if you want to see on Mac, you can check activity monitor. You can see this is my activity monitor, right? If I go to memory, see I'm in the memory. So all of these processes are running. For example, I'm running Mozilla Firefox. So it is shown as a piece of software that is loaded as a process. See, all the process names are there. So Mozilla in itself takes 12 GB. It is taking 12 GB of my RAM, right? Quite a good chunk it is taking. Then let's say Zoom is also there. So it is taking 200 MB, right? Now let's say I close Zoom. Let's say here, I'm going to close Zoom. So let me put Zoom here. If you will see, Zoom is currently running. You can see this white dot. If I click on it and click on quit, right? So Zoom is now no more there, and you can see from my process list also Zoom is gone. So whenever you run a piece of software, it is loaded as a process. Now you might be thinking why I am telling you all of this. Now RAM is a primary storage area, or you can say it's a storage device. That means if a program is loaded as a process, it gets some memory allocated to it from the RAM. For example, my RAM was having 4 GB memory. So let's say the RAM allocates 512 MB to my process. I'm just giving a random example that when I run my program and it converts into process, some 512 MB of my RAM gets allocated to this process. Let's say I run another program and that gets converted to process, it will take some more memory and so on and so forth, right? So now what is the use case of this memory? Inside this memory, we can do some storage. As I just showed you that in the tic-tac-toe game, we need to store the player score. Maybe you want to take the name of the player also. So you might need to store the name of the player. So we need some storage area for all of this. And we can use this RAM as the storage area. And just think about it. Once we close the process, all of the data will be gone. When we will restart, we can restart from scratch. So whenever we are going to run a program, that program gets loaded in the memory as a process. This process gets some storage area from our RAM. That means inside our program, we can write logics so that we can store some piece of information very easily. And where that piece of information will be stored, that piece of information will be stored inside the RAM. So now we have to see that how can we store this piece of information. When we are dealing with a programming language, so inside programming language, there are some special words that we cannot use for our use case anyhow we want, right? So there are some special words which have got some special meaning to the programming language, right? We cannot modify it based on our wish. So these things are called as keywords. So in a programming language, few words are reserved by the language for its own purpose. We cannot change their meaning. Or repurpose them for a different use case. For example, let's say in English, you have some punctuation marks, right? These are reserved. If let's say there is a question, then it is definitely going to somehow give a feeling of a question asked, right? There are like vowels that are fixed, like A, E, I, O, U. These are vowels, right? So there is rule that only these 5 characters are vowel, right? So just like that, in programming languages also, there are some words that are reserved by the programming languages. Different programming languages can have different reserved words. These reserved words are not expected to be used by us for anything. They will be having their special meaning. They will be having their special use case. For that particular use case only you have to use the keyword. Otherwise, language is not going to allow you to do that. These kind of words are called as keywords. Right? So, for example, in JavaScript, few keywords are let, for, const, if, else, return, etc. There are a lot of keywords. I'm just naming a few. So these keywords, you cannot just use it for your own purpose. You can only use them for their intended purpose that is defined inside the programming language. This is defined inside the programming language. We cannot, I would say, change that. So these are reserved for the programming language. That's why we call them as keywords. So whenever I will say keyword, so you should get a notion that this is a word which is reserved for the programming language use case. So we are going to learn about that use case and we are going to move forward. We cannot just change the use cases anyhow we want. That cannot, like that particular thing can not happen. Now we know that we have keywords, and now we also know that we need to store some piece of information based on the software that we are trying to build. So how can we store some values inside a program? How can we store some values inside a program, or specifically saying JavaScript program? So to store values, we can use variables. Now you might be thinking, what are variables? Right? You might be thinking, what are variables? Right? So let's say that this is your RAM. Let's say this is your RAM. Okay. Inside your RAM, you got 512 MB for your particular process. Right? For a particular process, you got 512 MB. Now inside this 512 MB, what will happen is you want to store some piece of information. So technically, what you can do is you can create a bucket in the memory. You can create some bucket in the memory. Inside this bucket, you can store some value. For example, let's say 12. I'm going to store a value 12 inside this bucket. And this bucket will be also having a particular name. You can also name this bucket. You can label this bucket. So let's say name of this bucket is, let's say X. Okay, name of the bucket is X. So this whole bucket in which we are storing a value and we are referring it with a particular name, this whole thing is called as a variable. This whole thing is called as a variable. That is, you have to create some bucket inside the memory that can store some value, and that will be having a particular name using which we will be able to refer to it, that we are referring to this variable. Right? So variables are memory buckets that stores our values and has a name as well. Right? And has a name as well. So if let's say in your piece of code you want to store the information 12, or let's say you want to store my name as the information, what you will be able to do? You can just create a bucket, name the bucket, put the value inside the bucket, and you will get a variable. So this whole bucket is called as a variable, right? So inside variables, we will be able to store data. So inside them, we can store data, as simple as that. Now we have to think that how to make variables in JavaScript and how they actually work. Variables can actually hold your data. How to create variables in JavaScript, we are going to discuss in some time. But first of all, try to understand the concept of variables. Variables can hold your data. It is like a bucket in the memory that has been allocated to you inside RAM. So let's say your process has been allocated 512 MB of memory. So this bucket will be part of that memory, that let's say 10 MB of that memory this bucket took. Inside this bucket you are going to store some value, let's say for example 12, or let's say some example 12, or let's say some text you want to store, or something else you want to store. We'll see what different type of things we can store, but something you want to store. So what you can do, you can store it and you can give a name to the bucket, or you can say you can give the label to the bucket. So this is the label, this is the value, right? So using this label we will be able to refer to the variable, that what is the value present inside the variable, or if we want to update the variable, that thing we are going to discuss. But for the timing, just try to understand that variable is a bucket that can hold some value for you in the memory.